So here, actually, without, we need something called the Shanken reduction for without Shanken correction. Okay. Next, okay, let us practice Fama MacBeth regression one more time with multi-factor model. Here we will use Fama French three-factor model. Okay, we will use, not use, we will illustrate Fama MacBeth three-factor model. Okay, so we have three factors, so it means we have three betas. So here three factor means three factors are market factor, market size, and value factors. Market is usually denoted as MKT. Size is small minus big, and value is high minus low. Okay. So first, let us simulate factor loadings, i.e. coefficient. So first is BMKT. Okay, market factor, true betas for market factor. And random, let's say this is the 1 over n, but here, because of later, so that we don't have to transpose it. So true loading for market factor. And then next we have size factor SMB, small minus b. SMB for size factor. And then high minus low, it is a value factor. Value factor, okay. Next, simulate factor returns. Let's simulate the factor return. So let's say factor premium is the same to 6% per year for everything. So MKT is 0.06 multiplied by DT plus NP random standard normal. And then we have T1. Okay. So this is market factor. And then size factor, SMB, small minus b, it is size factor. And then this is value factor, high minus low. This is called value factor. Value factor. Simulate data. Simulate data, and so we have data. It's basically similar structure. So first risk-free rate plus now we have first market factor and then multiplied by market factor. Second, the size loading and then multiply size factor. Okay. And then wait, we can go up over here. How did we simulate? Okay. this is not in, sorry, this should be, I think this one, right? Because this is, okay, so I think this one, array. Let's take the shape. Okay, so fine, just multiplication does linear algebra over here. Okay, so here we will simply use multiplication over here. Okay, so SMB and then loading for value factor and then value factor. And then we will add the idiosyncratic risk. S is average idiosyncratic, average idiosyncratic risk, the same to before, and then random, standard, normal, and then Tn. Okay, so we simulate data. Let's take data shape. Shape is same as before. No wonder. Even let me check, even without this one, shape is same. Okay, shape is same. Good. Okay. So we can do same thing. So step 1, time series regression. Step 1, time series regression, form by form. Form by form. Form by form. So first, let's collect the factors. Factors. Factors is the market size value factor altogether. So MP column and then MKT size high, small minus b, high minus low. Okay. So I collected size factor and then B and P0 3. Okay. And then now we do the time series regression for I in range and for form by form, form by form by form, time series regression. Okay, time series regression, and then model we will do linear regression. Okay, and then we feed it model. Now we will feed with factors, and then for each form time series, so data for time series for all time for each form. Okay, now we collect P. So this is NP now. Row. Actually, we can column binding because it answers are column. So column binding B and then model coefficient column bind. Okay, and then P equals P. Now the first one is 0, all 0. So we remove this one. So we remove this one, but we keep everything, but we remove the first one. So start from 1 to the end. And then we transpose this one. And let's check B shape. Okay, so we have 2,000 forms. We have 2,000 forms, and for each form, because with 3 factors, we have 3 factor estimated factor loading. So that seems quite correct. Okay. Now, step 2. Cross-sectional regression, time by time. Time by time, right? So now F, MP0, 3. Okay. And then for I in range T. So it is time by time cross section regression. Time by time cross sectional regression. Okay. And then model is of course linear regression. Linear regression. And then model fit. Now it is linear regression. So our feature is B, and then in the data matrix, for each time, for all forms. Okay, this is important part. And then now we collect those F, and then model coefficient F, and then same. Now we'll do F equals NP transpose F, and then we keep everything over here and start from the first one to the end. Okay, F. And let's check F shape. So yeah, so we have, yes, the time series. So cross at 2,550 cross-sectional regression for three. So we have three coefficients there. So everything seems fine. Okay, so it is one. And then we can simply describe it. So now DF is PD data frame F